Hello everyone, good morning. Today we will be discussing about exploring the critical issues of operating support system support for database management systems. I'm going to explain each and every slide. Uh, Let me start with the first slide, table of contents. It starts with introduction and buffer pool management, the file system scheduling, process management and inter-process communication, consistency control, paged virtual memory, and conclusions. Coming to the introduction, we'll start by establishing the problem statement and highlighting the importance of addressing the mismatch between OS and DBMS requirements. Coming to the buffer pool management, we will examine the limitations of how operating systems typically manage buffer pools and discuss Stonebraker's proposals for improving this critical functionality. The function system will look at how the file system abstractions provided by OSs are ill-suited for the needs of database management and the novel approaches suggested. Uh, and the next slide is scheduling, process management, and inter-process communication. We'll dive into the challenges DBMS faced with OS provider scheduling and IPC services and the potential solutions. Coming to the consistency control, we'll explore how the separation of buffer management, concurrency control, and recovery between OS and DBMS leads to inefficiencies and discuss tighter integration proposals. Uh, the next slide is paged virtual memory. Finally, we will briefly touch on the limitations of binding files directly into virtual memory and the associated problem. Coming to the conclusion, we'll summarize the key takeaways and discuss the significance of this work in bridging the gap between operating systems and database management systems. Uh, I'll go for the next slide, the importance of the problem. The efficient and effective operation of database management systems is essential for a wide range of applications, from online transaction processing to business intelligence and analytics. However, the suboptimal interaction between OS and DBMS services can severely impact the performance and capabilities of these database systems. When OS support is inadequate, DBMS must resort to workarounds and duplicating functionality, which introduces overhead, complexity, and potential for errors. This ultimately hinders the ability of database systems to serve the needs of the application and organizations that rely on them. Addressing the limitations of OS support for DBMS is an important and long-standing challenge that deserves careful attention. By bridging the gap between the general purpose design of operating systems and the specialized requirements of a database management. We can unlock significant improvements in the efficiency, scalability, and functionality of the database systems. I'll go with the next slide is challenges. Reconciling the specific requirements of database management systems with the general purpose design of operating systems is a technical challenge endeavor. DBMS have unique needs across a variety of critical ranges, including buffer management. Buffer management is DBMS requires specialized buffer replacement strategies and prefetch or force out capabilities that are not well supported by typical OS buffer pool managers file systems. DBMS needs structured file abstractions and physical contiguous storage rather than just character array files. Scheduling and IPC. The process per user and server models used by OSs have performance limitations for DBMS architectures. Consistency control. Separating buffer management, concurrency control, and recovery between OS and DBMS leads to inefficient duplication of functionality. In addition to these functional gaps, the performance overhead of OS services is a major concern for database system, which require an efficient access to data and resources. Overcoming these challenges requires innovative OS designs and tight integration with DBMS needs. Uh, I'll go with the next slide, limitations and related work. First point is buffer pool management. Uh, Many modern operating systems provide a main memory cache or buffer pool to improve the performance of file input or output operations. However, this services has several significant limitations when it comes to supporting database management systems. Uh, First point is high overhead. The cost to fetch a block from the OS buffer pool to pool can require thousands of instructions, significantly impacting DBMS performance. Uh, sub, Next one is suboptimal replacement strategies. Uh, Operating systems typically use policies like least recently used LRU for buffer management. However, these generic strategies perform poorly for the access patterns common in DBMS workloads. Lack of DBMS support specific features. OS buffer managers do not provide interfaces for DBMS to specify custom replacement policies or leverage application specific preferred strategies. They also lack support for selective force out of dirty pages to assist with DBMS crash recovery. These limitations lead most advanced DBMS to implement their own buffer pool managers in user space rather than relying on the OS provider service. This duplication of functionality is suboptimal and represents an area ripe for improvement. I'll go for the novelty slide. Uh, Coming to the buffer pool tool management. To address the limitations of current OS buffer pool management, the paper proposes that operating systems should provide specialized interfaces and capabilities to better support the needs of database management systems. It allows DBMS to specify custom buffer replacement policies rather than relying on generic LRU. The OS should enable DBMS to implement replacement strategies tailored to their access patterns, which can significantly improve miss ratios. Uh, Enable DBMS-driven prefetch advice. Operating system should provide a mechanism for DBMS to inform the buffer manager about upcoming access patterns, allowing more effective prefetch. Offer selective force out capabilities. The OS buffer manager should support the ability to selectively force dirty pages to disk in the specific order required for DBMS crash recovery protocols. By incorporating these DBMS aware features into the buffer pool management, the paper argues that database system could leverage the OS service more effectively rather than feeling compelled to re-implement their own buffer managers in user space. I'll go with the next slide. Limitations of related work, the file system. Uh, the file system abstract provided by most operating system is also poorly suited to the needs of database management systems, specifically uh, character array objects, physical contiguity, integration of DBMS. Uh, I'll I'll explain one by one. I'll go with character array objects. Uh, Character array objects In character array objects, OS file systems typically treat files as character array objects, lacking the structured data models required by DBMS. I'll go with next physical contiguity. Database systems often rely on sequential access patterns. The dynamic file growth model used by OSs can result in blocks being scattered across the disk, causing excessive seek times. Integration of DBMS file organizations. DBMS require specialized file structures like B trees for indexing, which are not well integrated with the base file system provided by the operating system. We'll continue further with the novelty, the file system. The better support the file system requirements of database management systems, the paper advocates that operating systems should provide abstractions that are more closely matched to DBMS needs. Uh, First one is structured files objects. Rather than just character arrays, the OS file should offer structured data models supporting records, indexes, and other DBMS specific structures. Data structures. Extent-based storage. File growth should be managed through extent-based locations, ensuring physical contiguity for efficient sequential access patterns common in DBMS workloads. Integrated DBMS file organizations. The base file system should seamlessly integrate support for specialized file structures like B trees, allowing DBMS to leverage OS services without the need for duplication. By designing the file system with the specific requirements of database management in mind, operating systems can provide a more suitable foundation for DBMS to build upon, reducing the need for workarounds and custom implementations. We'll go further with the limitations of related work. Scheduling and IPC. Operating system support for scheduling and interprocess communication also poses challenges for the organization of database management system. Uh, Pre-process user model limitations. Many DBMS adopt a model where each concurrent user runs in a separate OS process. However, this can lead to performance issues due to the overhead of frequent task switches. Uh, Server model duplication. An alternative approach is for DBMS is to implement a server model where a central server process handles requests from client processes. However, this leads to be DBMS having to duplicate OS provided scheduling and IPC facilities within its own architecture. These architectural trade-offs highlight the mismatch between typical OS scheduling and IPC services and the optimal organization for high-performance databases. We'll go with the novelty again and scheduling at IPC. To better support the scheduling and interprocess communication needs of database management system, the paper suggests that operating system provide specialized scheduling mechanisms, IPC designed for database management system patterns. Uh, I'll explain step by step wise. Specialized scheduling mechanisms. The OS should offer scheduling facilities optimized for DBMS workloads, potentially include a fast path for DBMS processes to minimize the overhead of task switches. I'll go with next IPC design for DBMS patterns. The interprocess communication services provided by the OS should be designed to minimize overhead for the specific communication patterns required by different DBMS architectural models, whether process per user or server based. By tailoring these core OS services to the unique need of database systems, the paper argues that DBMS can be more effectively organized and operated without the need to re-implement scheduling and IPC functionality in user space. Further limitations of related work, consistency control. Uh, when a database management system maintains its own buffer pool management separate from the operating system, it also must duplicate OS provided concurrency control and crash recovery mechanism. This leads to an inefficient duplication of functionality between the DBMS and the OS layers. The OS typically provides file-level locking and basic crash recovery capabilities. However, DBMS require more fine-grained consistency controls, such as page-level or record-level locking, as well as advanced transaction management features like two-phase commitment protocols and log-based recovery. By separating these consistency control functions between the OS and DBMS, significant overhead and complexity is introduced, as the two layers must coordinate their operation and ensure correctness. Consistency control novelty. To address the limitations of separated consistency control between OS and DBMS, the paper explores the potential for operating systems to provide comprehensive transaction management support, including tightly integrated buffer management, embedded consistency control. So I'll explain point wise. First, I'll go with tightly integrated buffer management. The OS buffer pool manager should be closely coupled with the DBMS concurrency control and recovery mechanism rather than operating as a standalone service. Uh, Next one is embedded consistency control. The operating system should offer fine-grained locking, two-phase commitment, and log-based recovery capabilities as core services rather than relegating these critical functions entirely to the DBMS layer. While implementing this level of integration poses performances challenges that must be overcome, the potential benefits including avoiding the duplication of functionality and ensuring seamless consistency control across the OS DBMS boundary. Uh, we'll go with the contributions. The key contributions of the work of this work by Michael Stonebraker are identifying the limitations of existing OS services in supporting the unique requirements of advanced database management systems. Next one is proposing novel OS designs and interfaces to better meet the needs of DBMS, including DBMS aware buffer management, structure file abstractions, specialized scheduling, and IPC mechanisms for DBMS. Tight integration of consistency control functions between OS and DBMS. Uh, Next point is discussing the technical challenges and trade-offs involved in implementing these improvements to bridge the gap between OS and DBMS, advocating for closer collaboration between OS and DBMS designers to address these issues as the suboptimal interaction limitations, uh, the efficiency and capabilities of database system. We'll continue with the slide. Next slide. In addition to the novel proposals, another key contribution of this work is the detailed analysis and discussion of the challenges inherent in the current mismatch between operating system services and database management system requirements. By thoroughly examining the limitations of OS support in areas like buffer management, file system, scheduling, and consistency control, the paper lays the groundwork for future improvements. Furthermore, the paper advocates for deeper collaboration between OS and DBMS designers, recognizing that bridging this gap will require a concerted effort on both sides. Ultimately, the goal is to enable database systems to fully leverage the underlying operating systems rather than feeling compelled to re-implement core functionality in user space. This can unlock significant performance and capability improvements for database management, benefiting the wide range of applications that rely on this critical infrastructure. I'll go with the next slide, validation methodology analysis. The proposed solutions put forth in this paper are grounded in a thorough analysis of two key elements: existing operating system services and their limitation for supporting database management systems. The paper examines the shortcomings of OS provided buffer pools, file systems, scheduling, and consistency control mechanisms when faced with the unique requirements of DBMS. Design choice, second key element is design choices and trade-offs observed in real-world DBMS implementations, such as Ingress relational database systems and IBM's system are. By understanding how leading DBMS tackle the challenges posed by general purpose OS services, the paper identifies opportunities for improvement. This analytical approach, rooted in both theoretical considerations and practical DBMS experience, ensures that the proposed OS enhancements are well aligned with the actual needs of advanced database management systems. I'll continue with the next slide, validation methodology, uh, performance modeling. In addition to the analytical work, the paper also employs performance modeling and simulation techniques to quantify the impact of operating system limitations on database management systems. Specific areas explored through performance modeling include measuring the overhead and performance impact of OS buffer management services, evaluating the effectiveness of different buffer replacement strategies such as LRU for common DBMS access patterns. By modeling the performance characteristics of OS services, this paper is able to provide a more concrete understanding of the challenges faced by DBMS and the potential benefits of the proposed improvements. I will go with the next slide, validation methodology, practical integration challenges. Beyond just analytical and simulation-based evaluation, the paper also considers the practical challenges of integrating the proposed operating system enhancements with actual database management system implementations. This includes understanding the impact on critical DBMS functionalities such as buffer management and crash recovery protocols, file system organization and access patterns, scheduling and inter-process communication mechanisms. By grounding the solutions in these real-world integration challenges, the paper ensures that the proposed OS improvements are not just theoretically sound, but also feasible and beneficial in practice. Coming to the next slide, validation methodology grounded in real-world issues. In summary, the validation methodology employed in this work is firmly rooted in the practical, real-world issues faced by database management systems when working with existing operating system services. Through a combination of analytical examination, performance modeling, the consideration of integration challenges, the paper ensures that the proposed OS enhancements are directly relevant and applicable to the needs of advanced DBMS. This grounding in the practical realities of OS DBMS interaction is a key strength of the research. Conclusion, suboptimal OS support for DPMS. In conclusion, the paper finds that current general purpose operating system designs often fall short of efficiently supporting the unique requirements of advanced database management systems. This mismatch between OS capabilities and DBMS needs leads to significant performance issues and the need for DBMS to re-implement OS-like functionality in user space, causing duplication of effort and complexity. The core problem is that operating systems are typically optimized for a wide range of applications rather than the specialized requirements of database systems. This results in OS services that are either inadequate or introduce unacceptable overhead when used by DBMS. Conclusions, need for collaboration. To address these gaps between operating systems and database management systems, the paper advocates for closer collaboration between OS and DBMS designers. By working together to understand the specific needs of database systems and incorporating them into OS designs, significant performance and capability improvements can be achieved. This collaboration is essential as the suboptimal interaction between OS and DBMS currently limits the efficiency and effectiveness of database systems, which are crucial infrastructure supporting many important applications and organizations. Conclusion for potential improvements. The novel OS designs and interfaces proposed in this work, such as DBMS FA buffer management, structured file abstractions, specialized scheduling mechanisms, and tightly integrated consistency control, have the potential to greatly improve the efficiency and effectiveness of DBMS systems running on top of operating systems. By addressing the fundamental limitations of current OS services, these improvements can unlock significant performance gain and enable database management systems to better serve the needs of the application and organization that rely on them. Conclusion for overcoming challenges. The authors acknowledge that implementing the proposed improvements to bridge the gap between operating systems and database management systems poses technical challenges that must be overcome. However, they argue that the benefits of these enhancements justify the effort required. By overcoming the current limitations of OS support for DBMS, database systems can realize their full potential and better serve the diverse range of applications that depend on this critical infrastructure. The paper emphasizes the importance of this work in unlocking the performance and capabilities of database management systems. Conclusion for significance of the work. In summary, this paper exploration of the mismatch between operating system services and DBMS system requirements and the proposed solutions to address this gap represent an important contribution to the field. Improving the interaction between OS and DBMS can have a significant impact on the performance and capabilities of database systems, which are essential for many applications and organizations. The thorough analysis, novel proposals, and practical considerations outlined in this work provide a strong foundation for future efforts to bridge the divide between general purpose operating systems and the specialized needs of advanced database management. Continuation for the next conclusion slide, future directions. Looking ahead, the paper suggests that future operating systems should be designed with a closer considerations of the needs of database management systems rather than focusing solely on general purpose functionality. This will require continued collaboration between OS and DBMS designers to ensure that two components work together efficiently and effectively. By incorporating DBMS specific features and optimizations into the core operating system, many of the limitations and performance issues can be addressed. This could include built-in support for specialized buffer management, structured file abstraction, schedule mechanism tailored for database workloads, and tightly integrated consistency flow. Fostering this deeper integration between OS and DBMS is crucial, as database systems are such critical infrastructure for a wide range of applications. Bridging the gap between the general purpose nature of operating systems and the specialized requirements of database management can unlock significant improvements in the efficiency, scalability, and capabilities of database systems going forward. These are the references I took. Uh, this is the end of my presentation. Thank you so much.